Hello class, this is the fourth and final example on divisibility tests using mathematical induction. In this video it's a little bit different because we're not looking at, well, it looks to be the case that we have two variables, x and n, but always be mindful that we're only looking at the one variable. It's usually going to be n, but don't be distracted by there being two variables. The procedure is still very similar. So, as always, we begin. If the expression given to us is divisible by in this case, an expression, so if this expression is divisible by another expression, then it still is the same, that the first number should be some multiple of the divisor. And it must be the case that it's true, for any integer m is greater than or equal to 1. So first, as always, we test for the smallest value in the domain. So it becomes x to the power of 1 minus 1 is equal to m outside of x minus 1. Well, that's rather straightforward because x to the power of 1 is just x. Well, in this case, it's definitely true because m can just be equal to 1 because 1 times this is equal to this. So this is true for n is equal to 1 since m is equal to 1. Now for any integer, k is greater than or equal to 0, we assume the expression to be true for n is equal to k. So we get x to the power of k minus 1 is equal to m outside of x minus 1. Moving forward, we're going to prove now the statement to be true for this expression, so k plus 1. So now it'll become x to the power of k plus 1 minus 1 is equal to m outside of x minus 1. So the left hand side is equal to going to be x outside of x to the power of k minus 1 for the same reason that we break apart that integer, the index. And from here we are already stuck because it doesn't seem to be the case that we can make this look like this in any step from this point. So always looking back, we can find x to the power of k here. So if we just rearrange this, we get x to the power of k is equal to m outside of x minus 1 plus 1. Substituting that expression here, this will give us x outside of m bracket x minus 1 plus 1 minus 1. In case you miss where that minus 1 comes from, we're just following the previous step. Expanding this out, I'm gonna expand this a little bit more, just make it easier for my next step. Let's just move it down like this. You know what, I won't cheat because using an iPad I can do fewer steps like this. So I just expanded that expression. So we expanded m. And then now I'm going to expand this out. Get mx squared minus mx plus x minus 1. From here, this looks like we're going to do some factoring by grouping. This first expression, this first pair, I can factor out mx. So mx outside of mx times x will give us mx squared. So we need x here. Mx times something gives us negative mx. That'll just be negative 1. Plus, now if we take a look, this group, well, those two, these two terms look just like this. So if we group them like this, we can factor out the entire group. So it's going to be x minus 1 outside of mx times x minus 1. So we're left with mx plus 1. Now if we take a look, this is actually already of the form mx. In this case, m looks just like this. You see it? Well, if you don't see it here, I'll do a few extra steps here. So if we just go, if we let, let's say we let a, capital A, is equal to mx plus 1. The expression now can be written as a outside of x minus 1. So this entire, this entire expression here is now a, and that looks just like this one here. So going from this step, going back up to the top, you can say that this is of the form m outside of x plus x minus 1. We can say that this expression looks now like m x minus 1, which is equal to that right hand side. And as always, we need to conclude this by just, well, thankfully I've got an iPad because I can copy this out. From step 1 and step 2, the expression x to the power of n minus 1 is divisible by not 3, but x minus 1 for any integer n. Is that right? Oh, so I need to change that. Instead of n is greater than or equal to 0, it needs to be n is greater than or equal to 1. And that's our last example for divisibility tests and mathematical inductions. I hope that gave you an insight into applying mathematical induction to divisibility tests. Hope to see you in the next videos. Best of luck.